So, yes, Johannes, the floor is yours.
Thank you. Welcome everybody here. And as Ivan already said, I had the honor to coordinate the project, and I'm also very happy that we came so far that we can present something. And my duty now is to give a very, very short overview what we were doing during the project, and many of the things I'm now mentioning will be discussed and presented in much more detail during the next 2 days, and so it's just a first start and an overview. A very short description, just to remind you or to inform the present stakeholders. Whoops. Ah, yeah, okay. The project was running for 3 years, and we had 21 partners from all over Europe participating in the project, from universities, from the industry, and research institutions. And what we planned was to have as outcome a fully operational products, turnkey low-cost multi-sensor units, with a cloud-based turnkey information system. This was the plan. And what we wanted to do and what we planned to do is to cover somehow the whole cycle of an earthquake crisis by being better prepared, which is running under the technical term operational earthquake forecasting, then being able to measure as fast as possible parameters from an earthquake, and to distribute early warnings that there is an earthquake going on, and then to calculate as fast as possible the possible or the eventual impact of the earthquake to a region, to the society, to buildings. And of course, this circle is going around and around. After an earthquake is always before an earthquake, and all these parameters and all these things we can calculate and we can observe can be updated and so on. And this we wanted to put in one product in our project, during our project. And for this, we were developing the idea of a turnkey platform, how we called it, which mostly consists of units measuring different physical parameters, and also smartphone-based information collecting from the population, and also automatically. Then all this information is coming in what we called then the engines, which are calculating out of all this information which we can then distribute to stakeholders, to people who are interested to get and need to know as fast as possible information about an earthquake crisis. For this, we had test beds, we had areas, we wanted to test parts of our developments, and COVID was already mentioned. Maybe this is the part where we had the biggest problems during the whole COVID crisis. The installation at the different test beds was quite delayed because people could not travel, could not go in the field, and therefore also the installation of what we were developing was at the end not as far as we thought it would be possible from the beginning. There we have an impact on the project, definitely from the COVID crisis. The test beds we had were selected under different aspects. big cities, Bucharest, Romania. Oops, I'm getting here confused with this machine here. Oops. Some earthquake-prone larger regional area, here as an example the Pyrenees in France. Then the earthquake zones, the southern and the northern earthquake zone on Iceland. Then we had as one test bed the Gulf of Corinth here with the towns Patras and Egeo. Then the town or the harbor, especially as an industrial installation, the Tauro, the harbor in Tauro in Italy, and we had a test bed in the Netherlands, Groningen. Groningen is not really known for big earthquakes, but known for induced seismicity due to gas exploitation. So there are different aspects and different population and different cultural background. And the whole project was then, I would say, some project life cycle or so I would call it. We started with, in the project, to ask our stakeholders, our people who maybe want to use such a platform, about what do they need, how can we help them. And then we had the installations in the test beds. Then in all our institutions, the people started either to search for well-established methods, how we can use well-established methods in our platform, which are known from science, or where we have maybe to invest new things, we have to develop new methods, which we then as algorithms wanted to put in this engine, which is calculating all the different output. Then we have the platform, as I explained it just before. And of course, then we are more or less now in the last part of the project development, where we have to think about what have we really achieved and what can we exploit, what can we use from our developments in future installations, in future developments, and how can we disseminate our results. And the main outcomes now, after 3 years of the project, are this. As I said, we had permanent, or again and again, running interaction with stakeholders, and there we tested different aspects of what we thought could be interesting as a platform. And there were several rounds of interviews and questionnaires and demos. And at the end, this all was going in the final version of the platform. And as stakeholders, we were in contact with this is it. Civil protection, with first responders. We were working with critical infrastructures, general business things we were discussing, and of course with citizens. And one of the outcomes was, for example, that we tried to find a common non-specialist language, what we want to use in our platform, so that people who have not scientific earthquake research background can use it, the whole platform, and can use the outcomes. This, for example, was a very important part. Another important part was that we were thinking about how we can present the results as easy understandable as possible so that they can be used, and such aspects. So these things will be also discussed later. Then in the test beds, here are some pictures from installations at different places. We installed more than 150 instruments, seismic sensors, as they are, for example, also shown downstairs, in the field, somewhere in buildings to measure and to see how buildings are changing due to seismic waves going through the buildings. Are there destructive effects or not? and or somewhere in basements and so on. In addition to seismic sensors, this 132, we also installed displacement measurement units, which are based on using satellite information, with which we can relatively fast measure if something has really moved relative to another position, if there was a fault which was moving, and there we are hoping to measure in almost near real time on a centimeter level that somewhere a fault has moved by some centimeters, and then in the long term, of course, we may get measurements which are then with much, much higher precision and up to 2 millimeter or so. And here we have also some installations of such satellite-based displacement measurements here in the harbor, here in the such a sensor, and here in the field, somewhere in the field. Then we had all these algorithms and methods we collected from different ideas. Of course, nobody was in the project interested in to invent the wheel again. We are, of course, based on many centuries of work and decades of research. And so we concentrated on gathering information, but also developing new methods with short-term changes in seismic hazard due to, we know that the Earth is reacting differently in aftershock sequences, and if there was a big event, one can expect some aftershocks and such things. These are changing the hazard. Then rapid mapping and near real-time updating of shaking during the earthquake. Quick determination of source parameters, very important to understand what will be the effect of the earthquake. Then improved and efficient data communication between all this. There we were working on that the information flow is as fast as possible. Then one important point was the rapid loss estimation, to get an idea as fast as possible what is the impact of this earthquake. And of course, with this, one can of course then trigger emergency operations and such things, and give this further to how then the first responders can use it. Of course, here are pictures which have nothing to do directly with TURNKey. Of course, we were looking what other people are doing, as for example in Mexico or in Japan or in US or so. We have the exchange and know approximately what all they are doing also. And as already mentioned, there had been more than 30 scientific publications coming out and so on. So, and this whole package then was then implemented in the platform. And what one can take home from as key results from our project, we developed some new generation of decision support systems for the different stages of an earthquake cycle. We developed some new framework for risk assessment and updating risk assessment during an earthquake crisis. Then we had these low-cost new sensors based on satellite data for measuring displacement. Then we have some new steps in rapid estimation of shaking and using also there the information from citizens via smartphone apps, and which are then can be used to calibrate our expected risk and hazard impact. And of course, we have then the critical infrastructure and community resilience models, which are helping to develop further in the different areas to get a more safer society. And then we have, of course, the platform itself. based on an instrumental network, instrumental data, or citizen-based observations. All this is coming in an engine, we called it scientific engine, calculating in near real time the data and calculating the effect of the earthquake and providing output to possible stakeholders. And therefore had been developed a special graphical user interface which can be used. What one has to say, of course, is after 3 years, this cannot be bought now from the shelf. We are in a stage that we have put all the things together. We think it's running. We have tested it in very, very different versions, but it's of course not a product which can be sold at the moment. Yeah, there needs further developments. We need also further exchange and communication with stakeholders to get the different aspects of the things better and adapted. And we hope that there will be enough interest to do such work then in the future. And with this, I'm finishing now, and I thank you for your attention. And as said earlier by my director, I would like to thank especially here for today Sergio, who has done really a very, very big job here during the last months and worked here to get this meeting here to Alicante, and I'm really happy to meet you all here. Thank you.